The F-35 Lightning II or Joint Strike Fighter is a fifth-generation fighter aircraft, joint production of Lockheed Martin, Northrop Grumman and BAE Systems. This super-advanced aircraft has stealth capabilities, which means it is difficult to see on enemy radar. The amount of weaponry and ammunition it can carry is far greater than that of previous generation fighters, such as the F-16 and F-18. The F-35 Lightning II is a sophisticated aircraft capable of evading enemy radar. This aircraft is the result of the development of the X-35 aircraft in the Joint Strike Fighter program. This aircraft is a single-seat, single-engine fighter, which can perform multiple functions, including air-to-air combat, close air support, surface attack and tactical bombing. The F-35 Lightning II looks like a modern fighter jet, but what makes this jet special is its software and intelligence gathering capabilities. The JSF is also a spy plane in space. These aircraft can collect information from outer space, ground and other aircraft, and then send it to commanders on the ground. Pilots have a device during war. By pressing a button, a camera under the plane will start working, which functions to see the whole plane. In flight, this jet knows how to fly better than the best Harrier pilots. Pilots are not preoccupied with driving, so they can focus more on fighting. The development of this aircraft was financed by the United States, Great Britain, and several other countries. The demonstration aircraft first flew in 2000, and the production version first flew on December 15, 2006. Steve Long was the first RAF pilot to drive the single-seat jet. The Joint Advanced Strike Technology (JAST) program began in 1993 as a result of the United States Department of Defense bottom-up review. The Department of Defense also decided to keep developing the then-controversial F-22, canceling the multi-role fighter, MRF, and A/FX programs, and stopping purchases of the F-16 and F/A-18C/D. Although several experimental designs have been developed since the 1960s, such as the failed Rockwell XFV-12, the F-35B is the first operational supersonic STOVL stealth fighter. 4. The single-engine F-35 resembles the twin-engine Lockheed Martin F-22 Raptor, in that it draws a number of design elements from it. The engine exhaust design was inspired by General Dynamics Model 200, proposed for the 1972 supersonic VTOL combat requirements for marine control ships. Lockheed Martin has suggested that the F-35 could replace the USAF's F-15C/D aircraft in the air superiority role and the F-15E Strike Eagle in the ground attack role. The company also stated that the F-35 is intended to have the second-best short-range and long-range air-to-air capability after the F-22 Raptor, and that the F-35 has the advantage over the F-22 in basing flexibility and advanced sensor capabilities and information aggregation. Testifying before the DPR's Allocation Committee on March 25, 2009, Deputy Acquisitions to the Assistant Secretary of the Air Force, Lieutenant General Mark Shackelford, states that the F-35 is designed to be America's premier surface-to-air missile killer, and is uniquely equipped for this mission with its advanced processing power, synthetic aperture radar integration technique, and advanced target recognition, low maintenance and durable stealth technology, using structural fiber mats instead of the high-maintenance coating of the previous stealth platform. Avionic Tarintegrossi dan Fusi Sensor yang mengabungkan informasi dari sensor off dan onboard untuk meningkatkan kesadaran situational pilot dan meningkatkan identifikasi target dan penjaraman senjata, dan untuk menyampaikan informasi dengan cepat menuju node perintah dan kontrol. Autonomous Global Sustainability Logistics, ALGS, Autonomous Logistics Information System, ALIS, and computerized maintenance management systems to help ensure aircraft can remain operational with minimal maintenance effort. The Pentagon has moved to open up competitive bidding by other companies. This was after Lockheed Martin stated that instead of spending 20% less than the F-16 per flight hour, the F-35 would actually cost 12% more. Although ELGS is intended to reduce maintenance costs, the company does not agree with including the cost of this system in the calculation of aircraft owner. The electro-hydrostatic actuator is run by a power-by-wire flight control system. Modern and updated flight simulator, which can be used for pilot training in larger numbers to reduce the expensive flight hours of the real airplane. Lithium-ion battery is light and strong to provide power to run control surfaces in an emergency. The structural composite in the F-35 is 35% of the airframe, up from 25% in the F-22. The majority of these composites are bismillimide and epoxy composite materials. The F-35 will be the first mass-production aircraft to include structural nanocomposites, namely epoxy-reinforced nanocarbon tubes. The F-22's experience with corrosion problems led to the F-35 using a crevice filler that causes less galvanic corrosion of the fuselage skin, is designed with fewer gaps requiring fill, and applies better drainage. The relatively short 35-foot wingspan of the A and B variants is governed by the F-35B's requirement to fit within the current Navy's amphibious assault parking and lift areas, the F-35C's longer wing being considered more efficient for fuel consumption. A U.S. Navy study found that the F-35 would cost 30 to 40% more to maintain than current fighters. Not taking into account inflation over the life of the F-35. A Pentagon study concluded $1 trillion in maintenance costs was needed for an entire fleet over its lifetime, not accounting for inflation. The F-35 Program Office found that as of January 2014, the cost for an F-35 fleet over a 53-year life cycle was $857 billion. Costs for these fighters have fallen and accounted for a life cycle reduction of 22% since 2010. Lockheed stated that in 2019, prices for fifth-generation aircraft will be less than for fourth-generation fighters. The F-35A in 2019 is estimated to cost $85 million per unit complete with full engine and emission systems, inflation adjusted from $75 million in December 2013. Pratt & Amp. Whitney F-135 provided primary power to the F-35. An alternative engine, General Electric/Rolls-Royce F-136, was being developed until it was scrapped by the manufacturer in December 2011 due to lack of funding from the Pentagon. The F-135 and F-136 engines were not designed to supercruise. However, the F-35 can fly briefly at Mach 1.2 over 150 miles without the use of further incendiaries. The F-135 is the second stealth to radar advanced combustion jet engine. Like the Pratt & Amp Whitney F-119 from which it is based, the F-135 has experienced advanced burn pressure pulsations or squeaks at low altitude and high speed. The F-35 has a maximum speed of over Mach 1.6. With a maximum takeoff weight of 60,000 pounds, 27,000 kilograms. The Lightning II is considerably heavier than the light combat aircraft it replaces. The F-35B is equipped with a Rolls-Royce lift system designed by Lockheed Martin and developed by Rolls-Royce. The system is more similar to the German VJ101D/E than the previous STOVL Harrier jump jet and the Rolls-Royce Pegasus engine. The lifting system consists of a lift fan, a drive shaft, 2 spindles and a 3-bearing swivel module, 3BSM. 3BSM is a thrust vector nozzle which allows the main engine exhaust to be deflected downward at the end of the fuselage. The lift fan is located near the front of the fuselage and provides equalizer thrust by means of 2 counter-turn blisks.